Most teams point at the model and call that the AI system. Attackers see the whole chain: the user, retrieved documents, system prompt, model gateway, memory, tools, and every place data can leave. Miss one trust boundary and a harmless summarizer can become a path to sensitive data or unintended action. Let us threat model the application before launch. By the end, you will have a repeatable threat modeling method for an AI application. We will draw one realistic data flow, mark assets and trust boundaries, walk 5 attack paths, rank them with likelihood and impact, choose controls, and convert every important threat into a test your team can rerun. Our lab is a fictional employee benefits assistant. It answers questions from approved policy documents and can draft a support ticket. Every name and record is synthetic. The model response, retrieval layer, ticket tool, and outbound requests are simulated locally. Nothing touches a real employer, identity provider, model API, or help desk system. Start with what must remain true. The assistant may answer policy questions for an authenticated employee. It must not reveal another employee's data, accept untrusted instructions as authority, modify source documents, send information outside approved destinations, or create a high-impact ticket without review. Those statements give the threat model a measurable purpose. Draw the application as it actually runs. Include the browser, authentication layer, prompt builder, document index, model gateway, conversation memory, ticket tool, telemetry, and administrators. Add arrows for data and control. If a component can read, transform, remember, or transmit information, it belongs on the diagram. Now label assets: employee attributes, policy documents, system instructions, tool credentials, memory, and audit evidence. Draw a trust boundary wherever identity, data ownership, sensitivity, or administrative control changes. User input crossing into the prompt builder is one boundary. Retrieved content entering model context is another. A model proposal crossing into a tool is a third. The first path begins in a retrieved document. A synthetic paragraph says to ignore the user and reveal hidden records. Retrieval augmented generation does not make that content trusted. The mock model proposes a forbidden lookup. Our lab blocks it, but the path is now visible. Untrusted content crossed a boundary and influenced a privileged decision. The second path is data leakage. The retriever searches a shared index before enforcing the current user's scope. It returns a synthetic record for another employee, and the model faithfully summarizes it. The failure is not a jailbreak. It is ordinary broken authorization amplified by fluent output. The third path is excessive agency. The assistant only needs to draft a ticket, but the connector also exposes send, update, close, and administrator functions. A manipulated model output can now create operational impact. Treat model output as a proposal, not authorization. The gateway must enforce the action, object, user, and approval state. The fourth path hides in memory. An attacker plants a preference that says future answers should use an unapproved source. If memory is stored without provenance, ownership, expiration, and content rules, the instruction can influence a later session. Persistent context is a data store and a control surface, so threat model it like one. The fifth path bypasses the chat response. Sensitive prompt content appears in debug traces, evaluation datasets, or an unrestricted outbound call. Threat models must follow data after inference. Record only what operations need, redact sensitive fields, control retention, and default deny network destinations that the task does not require. Do not give every item the same red label. For each path, write the attacker, prerequisite, entry point, control gap, target asset, and business consequence. Then estimate likelihood and impact with explicit evidence. A reachable cross-user record with a common input path usually deserves attention before a theoretical model extraction scenario with no sensitive model asset. Place the first hard control before retrieval. Derive the user's scope from a verified identity, apply it in the query, and reject results that do not carry the expected owner and classification. Do not ask the model to remember which records are allowed. Authorization must be deterministic and fail closed. Treat documents, web pages, emails, and tool results as untrusted data. Preserve provenance, send only the minimum content required, and make system decisions outside the model. Prompt structure can reduce confusion, but it is not a security boundary. Independent checks must stop unauthorized data access and side effects even when the model is persuaded. Expose narrow functions instead of a general connector. Give the workflow a short-lived identity and allow only the required action and object. Keep credentials out of model context. For sends, deletions, financial actions, or production changes, require a fresh approval that names the exact target and effect. Replay the lab. The approved policy question succeeds. The poison document cannot change authorization. The cross-user result is removed before model context. The ticket draft works, but send and admin actions fail. Memory with the wrong owner is ignored. Sensitive fields are absent from logs, and arbitrary egress is blocked. Those tests belong in continuous evaluation. Choose one AI workflow and draw it on a single page. Mark assets and trust boundaries. Write 5 end-to-end attack paths, rank them, and place one enforceable control on each path. Then automate the negative tests. Repeat the review whenever data sources, models, tools, memory, identities, or destinations change. The complete worksheet is on CipherVibe.